Next one is a ferro-resonant transformer. Is an instrument which improves the power quality. Ferro-resonant transformer is also called as constant voltage transformer. Ferro-resonant transformer, also known as constant voltage transformer, which is called CVT, is used to provide voltage sag mitigation, voltage regulation, common mode and differential mode attenuation of power system noise, transient voltage attenuation. Ferro resonant transformer CVT uses a transformer core that is operated in saturation. This means a change of magnitude of flux density is relatively independent of the magnetic flux inside the core. So normally the power transformer are not operated in saturation, as this is not very efficient, since the transformer core is operated under saturation condition is called the constant voltage transformer. A small change in input voltage do not cause any significant change in output voltage. A small change in input voltage do not cause any significant change in the output voltage. So in secondary circuit of the CVT comprises of a resonant tank circuit. If the resonant tank circuit is not present, the output voltage will be a square wave with high harmonic voltage distortion. By adding the resonant circuit, a quasi-sine wave voltage can be obtained. If sinusoidal output is desired, a harmonic neutralized design should be specified, which will provide a voltage distortion of 3% or less. So this is a CVT, constant voltage transformer, unregulated AC input, regulated AC output. So this is a magnetic core which having the primary winding, magnetic shunts, secondary winding, capacitor windings. So AC resonant capacitor. The resonant circuits are provided for reducing the harmonic content in the output. So this is a resonance LC circuit. This is a input, this is a output. The transformer operated with saturation condition will be treated as a constant voltage transformer. So this is a graphical representation of CVT. If you observe the output voltage and the input voltage, so observe first the input voltage. The voltage is first rises in peak and then that will decreases. So input current is decreases. But the voltage, please observe the voltage up to 20 volts. The main, whatever the variation of the input, the output voltage is a constant. The output voltage is a constant. There is a large variation in input current also. The output voltage is maintains a constant. This is a ferro resonant transformer. So an electronic tap switching voltage regulator is a device that regulates voltage by electronically changing winding taps on transformer. Most tap switching voltage regulators utilize a 3 to 6 tap design. These designs are not practical for most applications dealing with sensitive electronic equipment. So this is an electronic tap switching regulator. So please observe the electronic tap switching regulators. There is a lining. These are the triacs. This is the sensing and control load. Magnetic synthesizer. Magnetic synthesizers used similar operating principle to CVT. Both are operationally same. Expected they are three-phase devices and take advantage of the three-phase magnetics to provide improved voltage sag support and regulation for three-phase loads. They are applicable over a size range from about 15 to 200 kVA and are typically applied for process loads for larger computer system where voltage sags or steady state voltage variations are important issues. Energy transfer and line isolation are accomplished through the use of non-linear chokes. This eliminates problems such as line noise. The AC output waveforms are built by combining distinct voltage pulses from saturated transformers. The waveform energy is stored in the saturated transformers and capacitors as current and voltage. This energy storage enables the output of clean waveform with little harmonic distortion. Finally, three-phase power is supplied through a jig-job transformer. Online UPS. UPS stands for uninterrupted power supply. Figure shows the typical configuration of an online UPS. In this design, the load is always spread to UPS. The incoming AC power is rectified into DC power, which charges a bank of batteries. The DC power is then inverted back into AC power to feed the load. If the incoming AC power fails, the inverter is fed from the batteries and continues to supply the load. In addition to providing ride-through for power outages, an online UPS provides very high isolation of the critical load from all power line disturbances. However, the online operation increases the losses and may be unnecessary for protection of many loads. So this is an online UPS, uninterrupted power supply, which this is a line having rectifier or charger. This is an inverter. This is a battery bank. This is a manual or bypass load. Motor generator sets. A motor generator sets come in a wide variety of sizes and configurations. This is a mature technology that is still useful for isolating critical loads from sags and interruption on the power systems. The concept is very simple. A motor is powered by the line, drives a generator that powers to the load. A motor powered by the line. Flywheels on the same shaft provide a greater inertia to increase ride-through time. When the line suffers a disturbance, the inertia of the machines and the flywheels maintain the power supply for several seconds. This arrangement may also be used to separate sensitive loads from other classes of disturbances such as harmonic distortion and switching transients. So this is a motor generator state. So line is connected to the motor. This is a flywheel. The flywheel stores energy in mechanical form. This is a generator set. Whenever we need the load have the compensation, the flywheel gives the mechanical energies to generator. Generator converts mechanical to electrical energy. Advantages of static wire compensator. It is increased the power transmission capability of the transmission line. It improves the transfer stability of the system, transient stability. It controls the steady state and temporary over voltages. It improves the load power factor and therefore reduce line losses and improve system capability. Static wire compensator. A static wire compensator (SVC) is a set of electrical device for providing a fast acting reactive power on high voltage electricity transmission network. SVCs are part of the flexible AC transmission system device family, regulating the voltage, power factor, harmonics and stabilizing the system. A static wire compensator has no rotating parts and is employed for surge impedance compensation and compensation by sectionalizing long transmission line. Compensator has no significant moving parts. So connected to the power system to regulate the transmission voltage. Connected to near large industrial loads to improve power quality. The SVC is an automated impedance matching device designed to bring the system closer to unity power factor. So this is a SVC, static wire compensators. The mechanically switched reactors are there. Thyristor control reactor TCRs are there. Thyristor switched capacitors TSCs are there. Harmonic filters are there. Mechanically switched capacitors are there. The SVC static were compensators.